Welcome to my Introduction to Networking course, typically abbreviated ITN. This will be for the CCNA version 7 curriculum. Hello and welcome. This is Packet Tracer Lab 11.5.5 Subnetting an IPv4 network. Alright, so I already have the diagram off my screen. We have three main parts: designing a network, configuring the devices, testing, and troubleshooting. As always, read the background scenario. I'm not going to read it for you. You guys are more than capable of doing that. So let's jump right on in. Part 1, subnetting the assigned network. We have a 192.168.0.0 network. I'm going to read through this, and then we're going to go ahead and discuss. The first subnet is LAN A. You need a minimum of 50 hosts. The second subnet is LAN B, and you also need 40 hosts. You also need at least 2 additional networks for future expansion. Variable length subnets will not be used. All the device subnets should be the same length. So that tells me we're going to be using 50. Alright, so I have a blank PowerPoint that we're going to go ahead and open. And we're going to work through this real quick. Alright. Got my pen. Alright. I'd like to sit there and jump around, but whatever. 192.168.0.0. We have /24. We have 4 networks. $50, $40, unknown. It says we are not using VLSM. So that means we're going to treat all of these like the same size. Alright, so when we are looking at our 4th octet, those first 3 octets are locked in. We're dealing with the 4th octet. 3, 4, 1, 2, 3, 4. Two to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. That's how we get those numbers. So we have to figure out which network, which subnet gives us close to 50 hosts. No, 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 no. 32 is close to 50, but not quite. 64 and above will. So that means even if we did 40, 32 would not work, so it would still end up with the exact same subnet. So our subnet is 192.168.0.0/24, 25, 26. And that means each of the networks are going to be groups of 64. So the first network will be 0 through 63, 64 through, I can do math, 127, 128 through 191, 192 through 255. So those are our 3 networks. So let's go back to our packet tracer. Answer the following questions. How many addresses are needed for the largest subnet? 50. What's the minimum number of subnets required? We need 4 addresses, or 4 networks. The network that you're tasked with is 192.168. Oh, yeah. largest, shortest. What is /24 subnet in binary? So we'll do this /24. That means 24 ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 32 bits, because that's how large an IPv4 address is. So this is this /24 in decimal. So next question. In the network mask, what do the ones represent? The ones represent the network portion. The zeros represent what we get to work with, which would be the host portions. All right, so we have a few examples they want to work us through. So, /25. Here's 8, here's 8, here's 8, here's 1. That makes 25 ones. So, what is this in dotted decimal form? 255, 255, 255. This is in the 128 spot. So that is our subnet. So, the number of subnets and the number of hosts. So basically, we look at how many zeros there are. There are 7 zeros. 2 to the power 7, which is 128, minus 2 gives us 126 hosts usable. We minus 2 because network ID and network broadcasts, that's how we lose those 2 bits. We have borrowed our 1 bit here. So when we look at total number of subnets, 2 to the power of 1 is 2. So we have 2 subnets with 126 hosts if we did a /25. Next question is 26, 27, 28, 29, and 30. So I'm going to do 2 more of these, and then you guys should have a good understanding. I'm going to erase. All right, we're going to do /26. 6 zeros. 2 to the power of 6. Yeah, 6 zeros. 2 to the power of 6 is 64 minus 2 gives us 62 usable hosts. We have 2 network bits. 2 to the power of 2 is 4. We have 4 networks of 62 hosts. All right, so instead of going back and forth, we're going to go to the next one, which is a /27, and just work through the math again. /27. There are now 5 zeros, 2 to the power of 5, 32 minus 2, 30 hosts. 2 to the power of 3 is 8, so there are 8 networks of 30 hosts. All right, so the next one would be /28. Let me erase this. Four zeros, 2 to the power of 4. 16 minus 2, 14 hosts. 2 to the power of 4 gives us 16 networks, because there are 4 ones. 16 networks of 14 hosts each. And it wants us to go all the way, so I'll just do a few more. 29. 3 zeros, so 2 to the power of 3, which is 8 minus 2, 6 hosts. 2 to the power of 5, 2 to the power of 5 would be 8 hosts, or 8 networks of 6 hosts. All right, next would be /30. Two to the power of 2, 4 minus 2, 2 hosts. 2 to the power of 6, which that gives us 64 subnets of 2 hosts. And actually, I misspoke. On the /29, it's 32 subnets. I did 8. That was a complete typo. So I'm going to redo 29. I screwed that one up. 29. 2 to the power of 3, 8 minus 2, 6 hosts. 2 to the power of 5. There are 5 bits here. 32 networks of 6 hosts. All right, so that answers most of our questions here. All right, so we've done those questions. So the question then becomes, considering our responses, which networks, consider your above responses, which subnet masks meet the requirements? We could do a /25 or a /26. /25 gives us 2 networks of 128, 126 usable, so that's overkill. We only need 50. Where the /26 gives us 4 networks of 64 addresses total, 62 usable hosts. So we're going to be doing probably /26. Last question. Consider your answer above. Which subnet meets both requirements and minimum number of hosts and the minimum number of subnets? /26 gives us 4 subnets with 62 usable hosts. All of that is greater than 50 usable addresses, so we are good. Considering your answers above, which subnet masks meet the minimum requirements of subnets? All of them do. /26, /27, /28, /29, /30. All of them give us more than 4 subnets. But again, it's not just how many subnets, but how many hosts per subnet. And we've already answered the next question. 192.168.0.0. That's first network, 192.168.0.64. Third network, 192.168.0.128. And then the last one is 192.168.0.192. So that takes care of our chart. All of them are /26s. All right, next step. Filling in our addresses. Use the first host address for the custom router interface. Use the second host address for LAN switch A. Make sure to assign the default gateway address for the second host for LAN A. All right. What we're going to do is I'm going to do LAN A first. I'm going to get logged in. So enable, configure terminal. I'm not in my global configuration. I want to set the IP address. So in this example, it'd be VLAN 1. Because again, switches don't have IP addresses. We will assign the assign the second host address to the switch. So IP address 192.168.0. Second usable would be 2. Subnet mask 192 or 225.225.225.192. Turn it on, no shut. All right. Since I'm already on switch A, use the first to the custom router. Use the last host on PCA. Make sure to assign that as a default gateway for the PC. All right, so I'll get on my router, get to my global configuration. So enable conf t. IP is going to be which interface? That'll be interface gig 00, so IP address gig 0/0. Interface, there we go. IP address 192.168.0.1, 255.255.255.192. No shut. All right, my link is up, my switch is up. PC, go to my desktop. We already know the default gateway 192.168.0.1. It said use the last address for PCA 192.168.0.62. 60. Let me go back to my chart. 64 is the next ID. 63 is the broadcast. So within the range, what's between 0 and 63 would be 62. Subnet 192 or 225.225.225.192. All right, that is good. All right, so custom router and that network is done. Those steps are done. Assign second subnet. Use the first to the custom router. Use the host and whatnot. Oh, you know what I did not do? assign the default gateway. So I'm going to go ahead and fix that on LAN A. IP. Exit, go back one. IP default gateway 192.168.0.1. Alright, that takes care of that. We're going to do the same thing, but we're going to be doing the other interface. So, with this interface, gig 0/1, IP address 192.168.0.65. Second network. Second network is 64 through 127. So 64 is the network ID. 65 would be the first usable address. Put the appropriate subnet. Turn on the interface. Alright, so that part's good. On the switch. Enable conf t. Oh, I fat fingered it. So I'm going to go ahead, fast forward a little bit. Enable conf t. What we want to do is interface VLAN 1, IP address 192.168.0.64 ID, 65 is the router, 66 would be the IP address. 255.255.255.192, that's that /26. No shut to turn it on. Set up the default gateway. 192.168.0.65. All right, first usable, done. Second usable and default gateway, done. Host. We will go ahead and do the gateway. 192.168.0.65. IP address, last usable would be 127. That's the broadcast. So 126 would be the last usable. 192, so 255.255.255.192 would be the appropriate subnet. All right, that takes care of all of those. Part 2, configuration. So, set the enable and secret password for the custom router, set the console, and set the host name. All right, so custom router. What we're going to do then is, all right, I'm at the global configuration. All right, first one is host name, customer router, enable, secret, class, 123. Set the line console 0. We want the password to be class 123. Prompt at login. Set the secret, set the console for login, router host name, configure gig 00 and gig 01 interface, and enable them. Did that. Save the running configuration. copy, run, start. All right, that takes care of part 2, step 1. So, part 2, step 2, configure the IP addresses on the interface VLANs on the 2 custom LAN switches. We already did that. Configure the IP addresses in Subnet and the default gateway on PCA and B. We already did that. Alright, test and troubleshoot the network. In part 3, use the ping command to test for connectivity. So, PCA. That's a little weird. So, I know it's not 63. Okay, thank God it did not let me do that one. The answer key actually showed it as 63, so that's why I was like, whoa. Alright, let's go ahead and let's ping some things. So, ping 192.168.0.1. Can we ping our default route, gateway from LAN A? Yes, we can. Can we ping the gateway for LAN B? Yes, we can. Can we ping the PC on LAN B? ARP, and then it went through. Can A communicate with the default gateway? Yes. Can B? Let's go ahead and check B. .65. Yes, B can. Can A communicate with B? Yes. We have a 95. So let's double check our results. Let's see what's going on. It did not like the console password. Oh, I did. Conf T line con 0 no password Cisco 123. There it goes. I retyped out the command and I put no in front of it, that way it knows which command to delete. And that was just a login. If we go back to either of the PCs, they can still ping everything. So we're good. We're at the bottom of the lab, and again, check results. Everything is showing complete. That is this lab in a nutshell. Questions, thoughts, issues, please let me know. Thank you.
If you have any questions or anything, please feel free to reach out. Again, with this material, being able to ask questions and discuss some of the topics in the lecture help build long-term retention, so do not be afraid to communicate with this topic. Again, I'm here if you need anything. Thank you.